In July 2024, a team of physicists from the University of Warsaw and the University of Oxford published a paper in Physical Review D, one of the most prestigious journals in theoretical physics, that did something the physics community had considered impossible for over a century. They made tachyons mathematically legal, not as a metaphor, not as a thought experiment, as a fully covariant quantum field theory, the same mathematical framework that describes every known particle in the Standard Model, extended to include particles that travel faster than light and, under Lorentz transformation, move backward through time. The paper resolved three separate contradictions that had dogged tachyon theory since Gerald Feinberg first formalized the concept in 1967, and the fix required something that should disturb you. In order for the mathematics to work, the future has to influence the present. Not might. Has to. The boundary conditions that determine how tachyonic processes unfold require knowledge of both the initial state and the final state of the system. The outcome constrains the origin. The destination shapes the departure. And according to Andrzej Dragan, the lead researcher, this isn't an interpretation. It's a requirement of the theory itself. Let's back up. Because what you were taught about the speed of light is not wrong, it's incomplete in a way that matters enormously. Einstein's special relativity, published in 1905, establishes that the speed of light in a vacuum, 299,792,458 meters per second, is the same for all observers in all inertial reference frames. From this single postulate, everything follows. Time dilation, length contraction, the equivalence of mass and energy. And from the mathematics, see a clear implication. Any object with real positive mass requires infinite energy to accelerate to the speed of light. You can get asymptotically close. The Large Hadron Collider accelerates protons to 99.999999% of light speed, but you can never reach it. The speed of light is a wall. This is what you learned in school. And it's true. For particles that start below the speed of light, what physicists call bradyons, from the Greek for slow, the wall is absolute. But here's what they didn't tell you. The mathematics of special relativity doesn't just describe bradyons. It describes three classes of particle. Bradyons travel below light speed. Luxons, photons, gluons travel exactly at light speed and have zero rest mass. And tachyons, from the Greek tachys, meaning swift, live permanently above the speed of light. They don't accelerate through the light barrier. They're born on the other side, created already superluminal, at the way photons are created already at light speed. And the mathematics permits this. The energy-momentum relation E squared equals P squared C squared plus M squared C to the power of 4 works perfectly for a particle with imaginary rest mass. Mass equal to some real number multiplied by the square root of -1. For such a particle, the energy is real, the momentum is real, and the velocity exceeds c. Always. In fact, a tachyon's velocity increases as its energy decreases. Give it less energy, and it moves faster. At zero energy, it would travel at infinite speed. The speed of light is not a ceiling, it's a floor for particles that start above it. This idea was first formalized by Oleksy Myron-Belaniuk, Vijay Deshpande, and E.C. George Sudarshan in 1962, and given a name by Feinberg in 1967. Feinberg was inspired, of all things, by a science fiction story, Beep by James Blish, which imagined an instantaneous communication device. He worked out the relativistic kinematics of superluminal particles and found them internally consistent. Sudarshan went further, arguing that tachyons should not be dismissed simply because they were strange. Photons are never accelerated to light speed, but created at it, and tachyons would be created above it by an identical logic. The physics community was not persuaded. For decades, tachyons remained a mathematical curiosity, something the equations permitted, but nobody took seriously, and because they seemed to create catastrophic problems. 3 problems, specifically. First, the ground state of the tachyon field appeared unstable. Any slight perturbation would trigger a runaway cascade, an avalanche of particles from nothing, the vacuum itself disintegrating. Second, the number of tachyons in a given region of space appeared to depend on the observer's reference frame. Change your velocity, and particles that existed for one observer would vanish for another. This violated one of the most basic principles of quantum field theory. Third, tachyons could carry negative energy, which opened the door to unlimited energy extraction from the vacuum and violated thermodynamics. These 3 problems were considered fatal. For over half a century, they kept tachyons in the category of theoretically possible, physically impossible. The speed of light remained a wall in practice, even if the mathematics whispered otherwise. Then, in 2020, Dragan and Arthur Eckert, the same Eckert who co-invented quantum key distribution, one of the foundational protocols of quantum cryptography, published a paper showing something unexpected. Tachyons, they demonstrated, do not actually create logical paradoxes. They create disturbances of causality, but disturbances of exactly the kind already known to exist in quantum theory. The EPR correlations, the delayed choice experiments, see the retrocausal interpretations that physicists had been arguing about for decades. Tachyons produce effects that are structurally identical to these, not new paradoxes, familiar ones. This was a crack in the wall. And in 2023, Dragan's group extended special relativity to include superluminal observers in spacetimes of more than 2 dimensions, a mathematical obstacle that had blocked progress since the 1960s. The path was now clear for the 2024 paper. Here's what Dragan, Eckert, Patzos, and their collaborators actually did. They showed that all 3 fatal problems, the unstable vacuum, the frame-dependent particle count, the non-covariant commutation rules, had a single common cause. Physicists had been representing the Lorentz group, the mathematical structure encoding how different observers relate to each other in special relativity, in a Hilbert space that was too small. The standard Fock space used for quantum field theory works fine for bradyons and luxons. But for tachyons, it's missing half the picture. The fix was to double the space. Instead of working in the standard Hilbert space F, they worked in F tensor product F star, a twin space that includes both forward in time and backward in time states. In this doubled framework, the vacuum becomes stable. The particle count becomes frame-independent. The commutation rules become covariant. Every contradiction vanishes. And the framework doesn't just tolerate the 2-state formalism developed by Yakir Aharonov, Peter Bergman, and Joel Lebowitz in 1964. It demands it. The 2-state vector formalism is singled out as the preferred interpretation of quantum theory. Not optional. Required. This is where you need to stop and decide what you think. Because the implications of this paper split into 2 irreconcilable possibilities. Drop A if you think tachyons are real physical particles, that the Dragan-Eckert framework describes something that exists in nature. Drop A if you think tachyons are a mathematical artifact, consistent but physically meaningless, like so many other solutions to equations that nature chooses not to instantiate. Lock it in. Because the implications of each answer are profoundly different. Theory A, the conservative position, says the paper is mathematically correct, but physically empty. So quantum field theory permits many consistent extensions that nature doesn't use. You can write down consistent theories of particles with spin 3 or spin 4 that don't appear in the standard model. Consistency doesn't imply existence. The OPERA experiment at CERN in 2011 reported neutrinos traveling faster than light, and the world went insane for 2 months, until they found a loose fiber optic cable. Every experimental search for tachyons has returned null results. Cherenkov detectors, which should detect the vacuum equivalent of a sonic boom if a charged tachyon passes through, have seen nothing. The tritium beta decay experiments at Troitsk and Mainz, which measured the neutrino mass squared and briefly returned a negative value. Tantalizing, because a negative mass squared would imply imaginary mass, exactly the tachyon signature, were later explained by systematic errors in the molecular excitation spectrum of tritium. The 1985 hypothesis by Alan Chodos that neutrinos might be tachyonic was criticized and constrained by precision measurements at MINOS and other facilities. There is, as of 2026, exactly 0 experimental evidence for any particle traveling faster than light in vacuum. The mathematics is clean. The universe appears not to care. Theory B says the mathematics is trying to tell us something, and we should listen. Because the Dragon-Eckert framework doesn't just rehabilitate tachyons, or it rewrites the causal structure of quantum theory itself. The critical prediction, a new form of quantum entanglement that mixes past and future states. Conventional entanglement correlates 2 spatially separated particles in the present, the EPR pairs, Bell inequality violations, everything quantum information science is built on. The tachyonic entanglement predicted by the new theory correlates temporal states. A particle's past and its future become intertwined in ways that have no analog in standard quantum mechanics. This isn't philosophical speculation. It's a mathematical consequence of the doubled Hilbert space that falls directly out of the covariance requirement. If the framework is correct, this temporal entanglement should produce measurable effects. Signatures in high-energy particle collisions, or anomalous correlations in neutrino oscillation data, perhaps even detectable imprints in the cosmic microwave background from processes that occurred before electroweak symmetry breaking, when the Higgs field had not yet condensed, and its excitations would have been tachyonic. This last point is the most provocative claim in the paper. The authors argue that tachyons are not merely possible, they are indispensable components of the spontaneous symmetry breaking process responsible for the formation of matter. Before the electroweak phase transition, roughly 10 to the power of -12 seconds after the Big Bang, the Higgs field existed in a symmetric state. Its excitations, the disturbances in the field, would have had the mathematical properties of tachyons, imaginary mass, superluminal propagation, and the standard treatment of this epoch uses the language of tachyon condensation, the process by which the field rolls from its unstable symmetric state to the stable broken symmetry state that gives particles their mass. What the Dragon-Eckert paper implies is that this process should be taken literally. The Higgs field excitations before symmetry breaking were actual tachyons. They traveled faster than light. They experienced the 2-state boundary conditions that require future states to constrain present evolution. And when the field condensed, when the universe cooled enough for symmetry to break, the tachyonic phase ended. The Higgs boson acquired its measured mass of 125 giga-electron volts, and the superluminal era closed. The universe ran faster than light for its first trillionth of a second. Then it slowed down, and the arrow of time as we experience it emerged from that transition. Meanwhile, The experimental frontier is not standing still. At Berkeley, Raymond Chiao's group has been working for years on tachyon-like quasi-particles, faster-than-light excitations in inverted atomic media. These aren't fundamental tachyons, but they obey the same dispersion relations. Maxwell's equations coupled to laser-like media produce solutions that are mathematically identical to tachyonic field excitations. Separately, in 2023, the researchers published evidence of potential tachyonic signatures in topological insulator junctions, purely electronic systems where superluminal excitations emerge from the band structure without any optical trickery. If confirmed, this would be the first detection of tachyon-like excitations in a solid-state system. Not proof of fundamental tachyons, but proof that the mathematics maps onto physical systems in ways that keep narrowing the gap between theory and observation. And in 2025, a separate line of research explored what would happen if a black hole's boundary conditions were modified to prevent matter from truly vanishing at the singularity. The result? The black hole acts as a time mirror, totally reflecting infalling light and matter backward in time. The reflected field propagates through the event horizon and escapes. The authors concluded explicitly that in this scenario, a black hole could function as a time machine, sending signals into the past. The connection to tachyons is structural. Both the time mirror black hole and the Dragon-Eckert tachyon framework require two-state boundary conditions, past and future, jointly constraining the present. Both produce temporal effects that violate the standard arrow of time, and both are mathematically consistent with general relativity and quantum field theory as currently formulated. Pull all the way out. Consider the scale of what's at stake. On the standard model of particle physics, the most precisely tested theory in the history of science, accurate to 11 decimal places for the electron's magnetic moment, describes every force except gravity and every known particle. It was completed in 2012 with the discovery of the Higgs boson. It works. It predicts. It has never been wrong when tested. And embedded in its mathematical foundations is a tachyonic phase that physics has treated as a mere formalism, a computational trick, for decades. The Dragon-Eckert paper says, take it literally. The tachyonic phase was real. The superluminal excitations were physical. The future constraining the present boundary conditions are not interpretation. They are structure. You live in a universe where the fundamental equations of physics have always permitted particles that outrun light and move backward through time. For over a century, 3 mathematical contradictions kept this possibility safely locked away. In July 2024, a team of 7 physicists published a peer-reviewed paper showing that all 3 contradictions arose from the same error, a Hilbert space that was too small, and that fixing the error resolves every one of them. And the fix requires that the future constrains the present. It predicts a new form of temporal quantum entanglement, and it suggests that the universe itself began in a tachyonic phase, that the first trillionth of a second of existence was superluminal, and that the matter you are made of condensed from a field whose excitations outran light. Nobody has detected a fundamental tachyon. The experimental record is clean. But the theory is cleaner than it has ever been. The first fully covariant, a Lorentz invariant quantum field theory of superluminal particles, published in one of the top journals in physics, with Arthur Eckert of Oxford on the author list. And the theory makes testable predictions. Temporal entanglement signatures, anomalous neutrino correlations, imprints in the cosmic microwave background from the pre-symmetry breaking epoch. If any of these are found, everything changes, not just physics, our understanding of time itself. So here's the question I want to leave you with. If the future really does constrain the present, If the boundary conditions of reality include not just where things started, but where they're going, then what does free will mean? What does causation mean? Is the universe a story being written forward, or a pattern being completed from both ends simultaneously? There may not be an answer, but for the first time, the question isn't philosophy. It's physics. So tell me what you think in the comments. And if you want to follow this series as we explore the most radical ideas in modern physics, including our next video on Hawking radiation engines, where physicists have calculated that a black hole smaller than a proton could power a starship to relativistic speeds. Hit the subscription link in my bio to subscribe to our YouTube channel right now. Because the speed of light might not be the limit you think it is. And the future might already know what happens next. I'll see you there.